problem here is that most Corda developers, so what I mean by Corda developer here are the companies that build Corda apps, build these consortiums out. Most of these guys will want to represent their customers on the ledger as well. And that's a problem at the moment because the assumption, the prevailing assumption when we first developed Corda was that to join the network, the Corda network, you have to be firstly approved by the doorman. So Jay and his team sits over in the operations side. They have to approve you. Lots of work for Jay. Imagine if there's like tens of thousands of people joining the Corda network, then that's not really going to scale very well. If we have to do sanctions checks on each one of those entities or people, that's not going to work. And of course, each one of those participants has to run a Corda node as well, as I explained before. So it doesn't really work. Those assumptions, I think, we proved to be false. So we need another way to figure out how to support small businesses and individuals on the network. So there was, I don't know if any of you were at CordaCon in 2017. Mike Hearn did a presentation on something called Maximus, which was a way to essentially split up the node into kind of logical subsets, such that you had each one of these subsets was called a flow worker, and it was essentially a mini node in its own separate process that could process workflows. There would be one overarching node, but many kind of sub-processes running in parallel. And we called this Maximus, and it turns out that it was too complicated to implement, given the way the node is currently architected. So if you guys want to know a bit more about that, you can, and you're a good listener, you can have a drink with Matthew Nesbitt and he'll tell you all about it. However, I'm not going to go into that too much today. Suffice to say, we have some work to do before we can implement Maximus. Now, it's worth noting actually that accounts are a complementary solution to Maximus. So Maximus is quite useful if you're, let's say, I don't know, platform as a service company that wants to offer Corda services to all your customers, such that each one of your customers has their own database and all of their data is isolated in a silo. That's what Maximus is really for, whereas Accounts is kind of orthogonal to that, and you'll see why when I talk about it in the coming slides. And of course, we need a solution that can be developed in a couple of months, not years. So again, if you have that conversation with Matthew, you'll find out why it's going to take a long time to do it. And the engineering team is working towards a modularization effort of the code base that will make it easier to develop something like Maximus. So actually, what are accounts? Accounts are not complicated. Maybe we've made it seem more complicated than they actually are, but it's really not that complicated. So it's just a library, it's a Corda app, with a lot of support that has been added to the Corda core, rather, sorry. But what it allows you to do is split the vault into multiple logical subvaults. That's it. You still got one node. However, you can split the vault up into multiple mini vaults. That's literally it. There's a whole bunch of infrastructure and various bits and pieces that we need to be able to do that, but that's ultimately what it is. So let me provide an example. So if we have, I don't know, Alice, who runs a Corda node. She has 10 states in her vault. Running Corda without the accounts Corda app, each one of those 10 states implicitly is owned by Alice. So the legal entity that is Alice Limited or whatever. However, if Alice runs the accounts Corda app, then what she can do is she can say, well, I'm the node operator. However, I don't necessarily own or participate in these states. I'm doing it on behalf of my customers. So she can set up an account, she can say set up 10 accounts, and she can place each one of those states in an account, such that there's 10 accounts and each account has one state. And we can say, oh, well, Alice can say, I'd like to see what states are owned by account 1, and of course there'll be one state in there, okay? So it's pretty simple. That's it. Any questions? Okay, cool. So high-level pictorial edition of that, for those of you that prefer pictures, which is probably most people, this is how it would work. So you've got your node, which is big outer box, and you've got these black things which are state objects, and instead of, imagine there being a non-accounts enabled node, these two boxes would be here and all the states would just be in the one box, but with accounts you've got these kind of sub-boxes here, so you can allocate states to a particular account. So how does this actually work at a high level? So you have your key management service, which is just a thing that creates key pairs, public-private key pairs, and these are used to sign transactions. So the private keys are used to sign transactions, and the public keys are used to participate in states. The public key is what signifies your ownership in a particular state object. So they're pretty important. And we have this thing called an identity service. And the identity service, so Alex alluded to the identity service in some of his questions. He said, well, you know, how do you map a public key to a account ID? How do you map the public key to an X500 name, to the name of the node? Well, that's all done in the identity service. So you can see here that we can map a key to an account, and we can map a key to a node. So there are two main mappings in the identity service. One to X500 names, which is the name of a node, and another to what we call a unique identifier, or an external ID, or an account ID. So we've got a mapping from public key to node name and public key to account ID. And if you participate in a state with a key that is mapped to account 1, then we say that that state is owned or participated in by account 1, and that's it. So it took a long time, it was very frustrating, very laborious, to get agreement within the whole engineering team around how to do this. It's taken about 9 months. But the good news is that we have an agreement on how to do it now. And there's a reason why we chose this particular way of doing it. There were two other ways. One was to not use public keys at all. And the benefits of not using public keys is that if you're transacting a state between two accounts on the same node, if there's no signature required, then you don't actually need to use the notary service at all, right? You can just literally do an accounting entry twiddle and say, oh yeah, this is like what a bank would do. You just do an atomic swap from one account to another on the same node. Now that's quite advantageous because you don't need to use the notary. It's also a much more simple scheme. However, the downside of that approach is that it works particularly well for fungible things that only have one owner at any one time. However, if you have a linear state that is participated in by more than one party on the same node, then you cannot represent it particularly well with that scheme where you don't use keys to map states to account IDs. You can only have essentially one owner for a particular state. So that didn't work particularly well. The other approach was to put IDs in state objects. But I don't think that's a good idea because it's a leaky abstraction. The abstraction of accounts leaks into the state objects themselves, right? So that means if you create a state object, you would have to create an accounts-enabled state object and a non-accounts-enabled state object. So for those nodes that don't want to use accounts, they've got this pesky account ID in their state object that doesn't really make much sense to them. So the way I tried to do it was make sure that this accounts module is loosely coupled to literally everything else in Corda. So you don't have to use accounts, it's not obligatory. However, if you do use it, then the abstractions are going to leak into everything else. So that's really why it's designed the way it is. The other thing is, the case is going to talk to you about later, wallets. Well, the motivation around using key pairs, public keys, is such that in the future, if we want to move the generation of those key pairs out into a separate process, so not within the node itself, but off the node, maybe in another country, in another data center, under the custody of another company, the company that has the account on this particular node, well, then we can do that. We've got the infrastructure already to be able to do it. So some people in the engineering team would say, well, you know, this is all bloody pointless because what's the point in having loads of different key pairs if they're still de facto controlled by the node? Completely agree, it doesn't really make much sense. However, the intention is that we can then move the generation of those key pairs out into a separate process, and we can perform the signing within a separate process. And that gives rise to the capability of wallets, which Case is going to talk about. So you may have like a Java app on your desktop or whatever, and you can imagine you're an employee in a company. You can I don't know, receive a message coming in to say, oh, well, Roger, you have to sign this. I can inspect the transaction. If I'm happy with it, I click a button. Signing happens on my machine, and then I send the signed transaction back to the node, and it does its thing. So you can imagine a workflow like that, or you can imagine something like a mobile wallet. So I want to make a payment of some, I don't know, Corda coin or whatever from me to Case, then I can just do it on my mobile phone, and the process would be very similar. So that's the motivation for why it is the way it is. But I will agree that the use of public keys at the moment is kind of overkill just for reducing the leaky abstraction of the account ID in the state. But I think this design will pay dividends in the future when we start doing wallets. Oh, any questions?
I have some questions. Do we have like a default account if we set up a new node? Default account?
It's a good question. Currently, no, we don't. But you can quite easily do it. So you just create a Corda service, and in the init lock for the service, you wait 10 seconds because there's a race condition. You can't do anything with flow straight away. But after the 10 seconds, you can just create an account and call it default account. You can do that yourself. So I don't like adding things like this to SDKs that are going to be used by the community at large, because you become very opinionated about how things are done. Not everyone will want a default account, so adding one is not necessarily useful for everybody. But if you do want to add one, then the effort to do it is very small. And perhaps what I'll do is I'll make a note and to add some instructions to illustrate to people how they can do that, because I can understand that it is useful for some use cases.
Another question, like sometimes we have some digital asset which belongs to a joint account, belongs to two accounts.
Yeah.
Do we have some recommendation how to do this?
Well, you would create an account, one account, and you would say the identity of this account is owned by Alice and Bob, just how a bank would do it today. Instead of saying that this account is owned by, this state is owned by multiple accounts. So you could potentially do it by using the composite key function in Corda. So this is a way, instead of using one public key, you can create trees of ownership structure. So you can say this state can be spent by this key, or this state must be spent by this key and this key. So that allows you to create like a joint account structure, and both those keys would be mapped to would have to be mapped to the same account. So you can do it that way as well. But I'd say that's probably a lot more complicated, and the easier way to do it in the short term would be just how your bank does it, which is if you've got a joint account with a partner, then you just say that when you receive the bank statement in the post, it will be Alice and Bob's bank account, right? Benefits. So it's pretty self-explanatory, really. So reduce cost. So I know one of our customers who was looking to implement are implementing a trade finance network. They've got this long tail problem whereby they have, I don't know, 20-odd participants that are going to operate full nodes. Happy days, they can do that because they're large companies and they have the expertise to do it. However, they have this long tail of small companies that are not going to be able to run nodes. So it's kind of unpalatable for them to go to their customers and say, guys, you're going to have to spend £1 billion, okay, that's excessive. You're going to have to spend £1,000 a year on running a node. They don't really want to do that, right? So instead, they can be in an account on a node, which is quite nice for them. So it's kind of like Corda as a service in some ways. So you would have this node operator that offers accounts capability to their customers. So yeah, the other thing is it allows non-node operators to be represented on Ledger. So now you can have individuals, so the likes of us, can participate on Corda. We can have our own key pairs. In the future, we'll be able to generate those key pairs ourselves. So we have sovereignty over our keys. So we're the only ones that are allowed to spend our states. So whereas at the moment we rely on the node as a custodian for those key pairs, but in the future, when we have wallets, that won't necessarily be the case. The other advantage here is that not all nodes have to support accounts. So I think that's quite good as well. You can have mixed networks, some nodes which are accounts enabled and others which are not. You can seamlessly send a state from an account on one node to another account on the same node, or an account on one node to just a regular identity on another node, and vice versa. So there's no problems there. There's no changes to the wire format. There's no changes to the flow framework. There's no changes to how you build a transaction. The way it works is you generate a new public key for an account, and you use that public key as the participation key. And because that public key is linked to an account ID, then that state will be automatically mapped to an account when it's stored in when the transaction is committed to the ledger and the state stored in a vault. So it's pretty simple to facilitate this. And then the fourth bullet point is it's kind of just to say, well, we got parity with all the other platforms now. It's like Ethereum, Fabric, I know pretty much every other platform had this combination, had this capability of accounts, and we didn't have it, right? So now we have. So we kind of got parity with the other ledgers now, which is good. Use cases. I'm probably less qualified to talk about this than some of the other guys in the room, because I'm not really out with customers talking about what they need. But I can talk about it, I guess, at a high level and intuitively, I suppose. So the obvious thing is that you can host multiple customers per node. So you can implement custody-like accounts or brokerage accounts. So you can have a situation where you got, I don't know, account A and account B, and account A owns these specific states, right? Just like how a custody firm would hold your specific assets. And that's quite a useful thing, especially for things like brokerages, where you have to hold client money and client assets, which is particularly important. As well as that, you can implement bank-like accounts. So, so the difference between a custody account and a bank account would be, with a bank account, all the money, so to speak, all the cash is commingled, and there's an off-ledger allocation of this cash to an account. You can do that with accounts, but you can also have accounts participate in those states directly, and then you have like a custody-like one. So you can do both of those things. Maybe you don't need accounts for your customers, and you might want to use it just for accounting purposes. So let's say you're a large node, you're a big company, big brokerage firm, and you want to separate all of your trading activity into books, like how trading firms do. Well, you can do that with accounts. Likewise, if you want to actually go further down into those books and segregate the books into employee books, so trader books, then you can do that as well. You can set up an account per employee, and again, when they have wallets, well, then they can sign their own transactions as well. So you've got accountability there and audit trails baked into the applications. So cryptographic audit trails, which are have obviously quite nice properties. The other thing that you can do is use accounts initially, and then migrate to a full node as and when you need to. So you can say to your customers, well, if you don't want to set up a full Corda node, but you still want them to participate, well, they can have an account on a node. And then when there's enough business such that they need a node, well, then they can move to that node. No, caveat, we haven't implemented that yet.
Well, we kind of what's the migration path from accounts to full node?
Sorry?
What's the migration path from being an account owner to having your own node, transitioning any information to that?
Yeah, it's a good question. Well, I guess firstly you would have to set up your own node, right? Yep. Then you would generate a key pair on that node, and then you would send all of your states to that key. Or you'll generate multiple keys and send all of your states to those keys. So that's if you don't control the private keys on the accounts enabled node. However, if you do control the private keys on the accounts enabled node, and you are confident in moving that private key material from one physical place to another, then you can use the same keys. And all you need to do is just send state and ref flow or send transaction flow, all of the stuff that you've got in the account enabled vault to the new node, and you don't need to use a transaction to do it. So we'll be looking at those two approaches, I think. But initially it will just be the former approach where you actually just generate new key pairs and send all the states to the new node. Obvious downside of that is on per transaction based pricing, that's not necessarily advantageous because you might have to pay a lot of money, but I'm sure there are ways that can be worked out. But as I said, caveat, we haven't actually implemented that yet. So in accounts version 1, that's a to-do. But I don't think it'll be difficult to do.
Wouldn't you run into problems if you were a participant on if you're in an account, or you're in a node where you have an account, you are a participant on a state, but not a controller of that state. So you don't have the ability to change it because somebody else holds the ability to change it. Yeah. You can send a copy of the state to your fancy new node, but whenever an action takes place on that state, you won't find out about it because your participation in the state will still be recorded with your old account.
Not if it's spent to the new.
But then if you don't control it, you're not empowered to spend it to the new.
Well, I mean that's an application level detail, right? So. Yeah. I mean, I wouldn't advocate building your states like that, but if you want to, you can do. I think
So I'm not asking for that, so I'm just sticking it up as a possible thing.
Yeah, I can see why that would be a complication. I have a think, get back to you.
Roger, I don't know if you said already, what do accounts look like from X500 name perspective to the network? Does it use the organization unit? So
accounts, actually, I cover this on the next slide, if you don't mind. Sorry, on the last bullet point is, this is the first step to handling key pairs outside the node that I've kind of discussed already. So, caveats. To answer your question, Eric, accounts are not identities. Do not go telling your customers that accounts are identities because it's wrong and they're not. They are. It's just a logical subset of the vault. It's not an identity. So if a customer wants to use accounts, they're going to have to roll their own solution for discovery, and they're going to have to roll their own solution for identity at the application level. And if I have an account on a node, I can generate my own key pairs. But those key pairs do not have an X500 name associated with them. They do not have a certificate chain associated with them. It's literally just a key pair. And I think this is quite nice because it allows people, we're not opinionated about how our customers, or we shouldn't be opinionated about how our customers do identity, whereas we have been in the past with PKI nonsense and whatnot.
Roger, sorry, just a quick question. But we still store the mapping from the public
key? I'll get to that in a second. So we shouldn't be opinionated about how identity is managed at the application level for individual participants on the ledger. However, as Alex notes, we obviously need a way to be able to map public keys to a host node, and that is done by way of the X500 name for the host node. So let's say if I set up a node with the X500 name Alice London GB, Well, any public key that is created for that account, for accounts on that node, will be mapped to that X500 name, so Alice's X500 name. So if I share those keys with other nodes because they need them to send state objects to me or transact with me or whatever, well, they will map those keys to Alice's node. So in the identity service, they can look up, they can say, hey, what node does this public key belong to? And it will say, yeah, Alice's node. Here's the party object for Alice's node, so you can initiate a session with her.
So why can't I just store the information about the other nodes, and why can't I use my key management service thingy to figure out which of these public keys are? As in, the table doing the mapping from public key to X500 would be much smaller if I just store the confidential identities of everybody else in the table, not mine, and use the fact that I've got a private key for the public key as an indicator that this confidential identity is me. Because right now we are duplicating kind of the same information, right? In a way.
So, I had this exact discussion with Matthew and Rick, and the idea is that the key management service is for node-generated keys only. Only stuff which has been generated by the node in question should be stored in the key management service. There should be 0 APIs that allow you to perform actions on key pairs, public keys that were generated by other nodes. So that's where the identity service comes in. So in the key management, I'm going to go over this in more detail after lunch, but the key management service contains a Hibernate entity and a cache which stores public key hash to public key and private key, and that's it. And they're only our keys, right? But the identity service contains a whole multitude of tables. So all the paraphernalia for the searching stuff that we don't need anymore, but it also contains a mapping of public key hashes to X500 names for our keys as well as everybody else's keys, right? It contains a table of public key hashes to external IDs for our keys as well as everybody else's keys. And it also contains a table of public key hash to public key for everyone else's keys. So if you want to, say, do some, I don't know, a Hibernate query or whatever, you can do exactly what you said, right? So if you can join the public key hash to external ID table to the public key hash to public key table, and there's not a null, then you know that the key has been generated on another node. However, if there is a null, then you know that it's been generated by our node. And you should be able to join on the key management service table and get a not null. So you should be able to kind of join those 3 tables together. I realise that's a bit confusing, but I went back and forth with Matthew and Rick on this, and they said, like, key management service is only for our keys. Because these APIs were initially on the key management service. And I kind of agree with them, it's confusing because the semantics of that service would have fundamentally changed after we added those APIs. So I can empathize where they're coming from. But I also appreciate that we are duplicating data and it feels kind of pointless. But you know, we've got our hands tied behind our back a little bit because we've got the compatibility of the APIs to maintain, right? So, but yeah, good question. Right. Oh, sorry, Caroline.
Sorry you've covered this already, but in more technical language. But am I right then that you can only ever see other people who have accounts in your business network? Because it's not on a kind of network level, and there'll never be, like, this will never be visible in the network map, for example, of a network.
Exactly right. So
it provides some benefits then for business networks in terms of hiding their members potentially just to that business network.
Yeah, sure. So indeed, you have to implement your own account discovery functionality. So that can be done out of band. That can be done through Corda flows, potentially. But you can share information about accounts on a need-to-know basis. So it's your prerogative whether you want to share it with other nodes or not. I guess that's quite beneficial from a privacy perspective, I suppose. But yeah, it fundamentally changes the way that you use Corda, because before the assumption was, well, everyone's in the network map, and I just need to look them up and then I send them some stuff. But now you need to figure out which node an account is actually hosted on. And of course, if accounts can move from host to host, then it becomes even more complicated, which is why we haven't implemented those features yet, because it adds quite a lot of complexity and edge cases, annoying edge cases to deal with.
To what extent do confidential identities play here? Are they relevant to this?
They are very relevant. So basically, all of the stuff that Will's done and told you about is the workhorse behind how all of this works. When you want to transact with an account, you have to request a key pair, and that's done with Will's confidential identities flows. So if you, when you want to share a state with another account and share the identities, again, that's done with Will's confidential identities flows. So the accounts flows wrap Will's flows and add some additional business logic, such as does this account, is this account actually on that node? If it's not, then we handle the error condition. If it is, then generate a key, send the public key back, that kind of thing. So yeah, it's very much confidential identities driven. So I realize that's confusing in some ways, because we shouldn't really have called the feature confidential identities. But the reason why we did is because it was called confidential identities before. So it's parity for people that were using that feature before. But really what we should have just called it is key management or something like that.
So the reason why I asked is, I mean, you mentioned that application level solutions for account identity would be required.
Yeah.
But is there any default sort of first step that you would advise for anyone looking to implement this? Ways to do that?
It's a good question. So you can quite easily do your own thing in a Corda app. So let's say, for example, you can add a couple of flows that just, if you don't care about privacy, that share all of the account infos. I'll talk about that in the next session. The account infos for all the accounts on your node with all other nodes. So you just broadcast them to every other node. Then every node has essentially a mapping of which accounts are on the other nodes, and obviously which node it belongs to. So you can do that. Or you can share them on a need-to-know basis. You can create like a lookup service, but that's more effort. That would be something that potentially we can work on in future versions. I don't want to be opinionated about how to do this, because you speak to some people and they're like, oh, we really like self-sovereign identity and we want to use like a decentralized solution for this. Regardless of the fact of whether that's nonsense or not, they can do that. I don't care. If they want to use, I don't know, a similar approach where you get like claims attested by, I don't know, authoritative parties for, I don't know, particular attributes of an identity, yeah, they can do that as well. But the key thing is that they don't have to use PKI, because that turned a lot of people off, I think. It wasn't acceptable for all use cases.
Thank you.
But yeah, the downside is we haven't got any kind of solution out of the box for that. People have to use their imaginations. So the last caveat, which is a pretty big deal actually, it could be a showstopper for some people. There is no isolation between accounts in the vault. There's no isolation, process isolation, there's no data isolation whatsoever. So all accounts share the same transaction store, they share the same vault as well. So if you want to query, do a vault query on a per account basis, you have to specify a special incantation of the vault query criteria, and I'll go through that in the next presentation. But it's very important to note that there is no isolation. Like if you incorrectly write your Corda app, then you can return other people's states, other account states, and you may not, or you obviously don't want to do that. I think some use cases have requirements such that that data for different entities need to be separate, completely separate, isolated. And if that's the case, then accounts is probably not the solution. They would have to use separate nodes.